All right, we're going to do a quadratic overview, and we're going to do some applications with quadratics. That means we're going to review and bring everything together that we've learned in this chapter and then we're also going to do some word problems with these quadratics, because these actually have application to a ton of things in the real world. This is section 5.8. Let's get started. Our overview. I'm going to ask you some questions, and I want you to answer them out loud with me. You ready? What is the standard form of a quadratic equation?
Y equals ax squared plus b.
Bx plus c. There we go. All right.
Go ahead.
We got it right there. Y equals ax squared plus bx plus c. What is this graph? A parabola. A parabola. Anything that has an x squared in it is going to be some kind of a curve. And if you have y being a single exponent and x squared, you're going to get a parabola. That is correct. What does this a value up here, how does this a value affect the graph?
How wide it is and how wide.
Okay, how wide and how skinny and how else? That's true. How wide it is.
The slope is.
Yes, in a sense, what its slope is.
Intervals, the negative and positive.
The negative and positive also, how does that affect it?
Up and down.
If it's smiling or frowning, right? Okay, so that a value makes the intervals for our pattern similar to like a slope of it, and if it's upside down or right side up, correct? Okay, I agree with all those. How does the c value out here, how does that affect the graph?
It's oftentimes the y-intercept.
It's always the y-intercept. It's always the y-intercept of the graph.
It doesn't cross there, and the answer's still correct.
Yes, it does cross there.
It always does. It always does, because if x is 0, if these x values are 0, then they go away, and y will equal the c. And so it will be 0, that letter. So c is always. So if you don't know that, write that sum down or down.
I knew it was the y-intercept. It was just maybe I'm thinking of it in a different when I'm thinking of the vertex form.
Sometimes it doesn't. The vertex form is not.
Okay.
That is the k value, and it is not the c value. Okay.
Maybe
Only in the standard form does the c value. Yes. Good observation. All right. When does this graph have a maximum?
It's frowning.
When it's frowning, right? So when it's upside down, right? So when does it have a minimum?
When it's like this.
Smiling.
Right? When it's like this. I got you.
And the a is a positive.
Yes, when a is a positive. It has a minimum when a is positive and it's smiling, correct? Okay.
Yes.
All right. So how do you find that maximum minimum point? Well, if you remember, a maximum and minimum is the same as the vertex. And the vertex can be found by finding the x-coordinate of the vertex using the formula negative b over 2a. And once you find that x value, you plug it in to the x values in the equation. How do we find, or how do you find, where it crosses the x-axis? Well, it crosses the x-axis where the y value is equal to 0. And so that would be where this value right there would be 0. We have been doing that most of this chapter. We have been finding the solutions to that by taking the square root of both sides, by completing the square, by factoring, by doing the quadratic formula. We have been finding where it crosses the x-axis all along. The last question on the slide is, what does the discriminant tell you about the graph? The discriminant tells us how many solutions we will have. If you remember, our 3 possibilities was if the discriminant was positive, negative, and 0. Remember that if it was positive, it told us that we had 2 real solutions. If it was negative, we had 2 imaginary solutions. And if it was 0, we had 1 real solution. So your discriminant tells us when you have 2 real solutions, this is where it crosses the x-axis 2 times. Here, if you have a negative or 2 imaginary roots, this is where it does not cross that x-axis at all. And this last one is where if it's got a 0, it's got 1 real solution, it's where it crossed the x-axis 1 time, or the vertex crossed that x-axis. So it tells us how many times we're going to cross the x-axis. 2 times, no times, or 1 time. Let's do an example of number 1. I've got a graph there. I've got the standard form of an equation. We do not know the equation of that graph, but we can still answer several questions based on what it looks like. Letter A says, what do you know about the value of A? The value of A right here tells us how the graph either turns up or turns down. And since this graph is smiling, we know that that A value is positive. So we can just say that we know that A is positive. Letter B says, does this have a maximum or a minimum? Well, this thing goes up forever and ever, and so it doesn't have a maximum at all. It keeps going on forever, but it does have a lower point right here, and it's called the minimum or the vertex, and the vertex is a minimum. If it would have been frowning, it would have had a maximum right there. Letter C. Letter C does, what will the discriminant be? Positive, negative, or 0, and why? This is the only one that you have a y to explain on it. This crosses the x-axis 2 times. It crosses the x-axis 2 times, so you know that these are 2 real solutions. If it had 2 real solutions, it must have been positive. And so our answer over here is that it is positive because it crosses the x-axis 2 times. Actually, let's talk about some other possibilities here. Let's talk about the possibilities of how we could have other solutions. So if I had a graph that looked like this one, where it did not cross the x-axis at all, this would have 2 imaginary roots, and that would have been negative. And that graph could have been upright, could have been anyway, but it just doesn't cross at all. That would have been a negative. Now, if I had a graph where the vertex actually sat on the x-axis there, that would have been the one real solution. And that's where it would have been equal to 0. Okay? And it could have been sitting upright also, upright on that x-axis, as long as the vertex is right on that x-axis. Let's do letter D. What is the name of this graph? This graph is called a parabola. And last, let's do E. What is the value of C? C is where it crosses the y-axis. And our y-axis right here, our graph crosses here at a value of 0. 0. All right, we're done number 1.
So we're going to be doing applications with quadratics. I'm giving you a formula, and I'm going to dissect this formula for you so you'll know what each of the pieces mean. This formula would be used for anything that's dropped, or a projectile, something that was launched from something else, somebody that jumped off something, somebody that just jumped in the air. Anything that has gravity acting on it will be here. Gravity in motion, I suppose. You just standing there is not going to do it.
Why are we doing science?
Because this math is the reason we do science, and the reason science was developed and pondered and thought of, and I don't know if developed is always the right word, but
Yeah.
discovered and used is so that it could be applied to something. Okay, so let's start off. This is, since I've told you that this has to do with something being launched or something that's thrown or something it has a height. So
Height times time?
this t is time. That's what I'm going to start with. T is time. I want you to notice that time is a lowercase t, and it needs to
Velocity.
stay that way. Yes. The v with the little sub-zero, the sub-zero means this is when time is 0. So this is at the very beginning. Anything that has a sub-zero means at the beginning or initial. So that v sub-zero is your initial velocity. All right, so it's the initial velocity. For example, if you're shooting a gun, it would be whatever the gun's initial velocity that it gave it.
So like when you hit the trigger, right?
When you hit the trigger, and you'd have to have something that can calculate how much that velocity was. If you have, if you're throwing a ball, it would be how fast it comes out of your hand. All right. If you drop something, you might put a little note with this. If you drop something, you didn't throw it at all. You gave it an initial velocity of nothing. If you drop something, the initial velocity is 0. That would be something good to write down. Dropped, VO is 0. If VO is 0 and you multiply that by t, that whole term goes away.
Is that a VO or a...
That's a VO times t. And that t, both of those times are the same t. So you can put a little arrow to both of them if you wanted. Okay? The H. And since it has a sub O, it'll be initial. Your initial, and H is for height. Because gravity works on things and it accelerates as things go down, the longer it's in the air, the faster and faster it's going to get. So if you drop something from here and it hit the ground, gravity would be working on it longer than if I held it high, and so its speeds would continue to get faster.
That's not true.
Eventually, there will be a terminal velocity, but in this house, it's not high enough for the terminal velocity. But you're right. There is a terminal velocity, especially like from airplanes and people going from, only because of the wind resistance. Okay? All right. Now we have one more thing we haven't talked about. The negative 16 always stays. And this, by the way, this formula will work if we're doing feet and not meters. This is not for metric. This is for the English measurements. So all your problems will be not in metric. This last h of t, that's not h times t, by the way. That's the height as a function of t. We've talked about functions before. That's h as a function of t. That's your final height. Okay?
What's to do with the 16?
The 16 is the coefficient of gravity. Okay? So because we're here on Earth and not on the...
So
That's a negative 16, and because gravity is pulling down.
So like that's the speed of it being pulled down?
That is the coefficient of friction of how much it's pulling
being
that
pulled
stuff.
down, yeah.
Yes.
Okay.
Yeah.
And then why do we square time?
Because time, the good question, all these are great questions. Much of this is because that's the way the actual gravity works. As every time you go a second and then 2 seconds and 3 seconds, it accelerates and faster. That's why it's squared.
That makes
Okay?
sense.
All right? Good questions. Any other questions? Fantastic questions. A little note that you'll want to put for this h of t, the final height, if it lands on the ground, its final height is 0. All right? If your initial velocity, if you drop it, your initial velocity is 0. If it lands on the ground, the final height is 0. Okay. Let's review really quick. This problem represents objects that go down. It can also, it's something when gravity is working, so it could be something shot where it goes up and comes back down. All right?
So just like a parabola.
Exactly. It's just like a parabola. And that's exactly what this is. If you notice, this is A, B, and C as our parabola. All your parabolas represent this. This is why I have this over here. And we're going to go through that. All right. The graph represents, if you're shooting something, and this is, so you're shooting it up at time 0. By the way, this stuff down below here would be, this would be before time began, which it really shouldn't be there. All that stuff should be gone. So, and all this stuff after it hits the ground again, that would be time gone too. So we're only going to talk about stuff above the axis. So all that stuff down here is going to be gone. This at time equals 0.
That's when it first shot.
That's when it's first shot. It's at the ground. This is going to be shot from the ground. This particular graph is showing. At time equal 2 seconds, it's going to be at its highest point. And then at time equal 4, it'll be back on the ground. Okay? So you could find how long it took for it to go to its highest point, which is called the what on that parabola?
Maximum.
The maximum or the vertex. And you know the negative b over 2a tells you the vertex. You could plug it back in to find that height if you knew the equation. If it asked you when is it going to hit the ground, the ground is going to be a final velocity of 0. So you're going to set this equal to 0 and solve the quadratic formula. Maybe it factors. Most likely in real life, your numbers aren't going to factor, so you're going to use your quadratic formula. All right. We talked about it crosses the x-axis is when it's going to hit the ground. We talked about it has a maximum. That would be, when it got to its highest point and back. remember I told you that the stuff down below doesn't matter, but even the stuff on this quadrant is not going to matter either. So this time at time equals 0, it's at a height of 3. Give me a scenario what that would be.
So someone walked up a hill first and then threw it?
Yes, or you're up on a cliff, or you're dropping something out your window, or you're going to...
They're not dropping it.
In this case, it's not going to drop. That's right. You're going to have to throw it up. And it's going to be its maximum at 1 instead of...
shot put.
Like a shot put. Yes, especially because the person, anytime you're shooting, you're going to be off the ground. And so anytime you shoot something, you're going to have whatever your height is of your shoulder, and then... So it won't be at 0 if you shoot a gun, unless you're laying on the ground prone, but you're still going to have something, right? Okay, so this one's going to be 3 meters, 3 feet, not meters, but 3 feet, 3 miles, 3 something. It's going to be off the ground going up and then coming down, and at 3 seconds, it will hit the ground. Okay? That's what a parabola, what you've guys been all learning about, has anything to do with outside world, okay? Outside of this room. All right, let's do one. This is number 5 in your book, and in your notes there. All right, we're going to... A rock is dropped into a deep cave that is 152 feet deep. Why did I give you this formula and there's something missing? It says use this to write the equation for the... It's minusing the v. Why?
Because it has no initial velocity.
Because it has no initial velocity. You just dropped it, okay? So I gave you the formula for you. What is the h0 going to be? 152. So our answer for letter A is h of t equals negative 16t squared plus 152. B, how long will it take to hit the ground? I'm telling you how many decimal places to give your answer. What do I do to find out if when it hits the ground? Am I looking for time?
I'm looking for time.
I'm looking for time. And what do I know by this statement?
We know the final height is
You know the final height is 0. Which of this in this formula represents final height?
T.
So that right there is going to become 0.
So we just solve for t after that.
So we just solve for t after that. So we're going to have a 0 equals negative 16t squared plus 152. Now, you have to make some decisions. You have been learning how to solve these equations. We learned how to take the square root of both sides. We learned how to factor. We learned completing the square. And we learned the quadratic formula. Which one would be easiest for us to do on this one?
Just bring over the 52.
Bring over, and I actually might bring over the 16, so it would be positive, but if you bring over the 162, you'll still divide by it, so it doesn't really matter. And so we would be doing the thing where we take the square root of both sides, correct? Yes. All right, so let's do that. I'm going to move the 16 over here. It'll be the same thing as what you're doing, but I'll have a 16t squared.
And then we just find the square root of how many times 16 goes into 152, and then you put positive and negative.
Yes. So I'm going to divide both sides by 16 when we're done, right? What is 152 over 16? And you know what? I might not even find the square root. I might not do anything. Just do t.
9.5.
T equals the square root of 152 over 16 and just put that in my calculator.
You have to do round your... Oh, never mind. I thought you were saying the answer.
So I might do this. Be cautious, you guys, when you're doing this. Make sure you do close your parentheses so it knows what's really under the square root in your calculator. Square root of 1, and the plus or minus, we'll talk about that in just a second.
So like this is what it should look like right there.
Yes.
I just did that. I just divided it first.
I got 3.
Yeah, that works also. 3 point, and we want 2 decimal places. So 3.08, does it round? The 08 rounded correctly? Yes. Okay, all right. Now, what do I write as an answer? Because this is a word problem and we need units. And we got 2 answers. Do we use both of them? That's
We put t equals positive or negative 3.08.
Cancel it out.
Well,
So-
it has to be a positive because it's time. You can't have a negative time.
That is correct. This would indicate 3 minutes before or 3 minutes after you even dropped it. So you couldn't be on the ground 3 minutes before you dropped it, unless that took you that long to pick it up. But it's only the positive that we're going to be using on this one. And it's so we have 3.08 seconds.
Do we get seconds?
Yes.
Where does it say seconds? How would we know to use seconds?
Very good question. This formula uses time as seconds, and
But it doesn't say something.
I know you're right. It doesn't show up there. I should have said how long does it take in seconds. 3.8, and that's why we're doing them together so you can ask these questions. Okay.
Wait, so
Will
like
all of these
how,
be in
Okay,
seconds?
no.
Yes, ma'am.
Okay, 6
Yes.
goes second.
A rocket is launched from atop a 101-foot cliff with an initial velocity of 116 feet per second. There's your seconds, neuron. I have left you some space in between them. I didn't on here, and that's not a problem. I have told you the formula. That won't always be the case, but it is here. And I've told you to let h of t equal 0. I want you to substitute the values into that formula.
So you just put the height and the velocity in there.
Okay?
So it's
0 equals negative 16t squared plus. Do we have the velocity? We do.
Do you have initial velocity?
Yes.
101 feet.
116.
116 feet.
What did you put in for h of t?
0.
Okay, 0. All right. And negative 16 t squared. We said the initial velocity was 116 feet. Don't worry about that.
116
T, exactly. And then your initial height is
101.
okay. That is letter A. Letter B. Use the quadratic formula to find out how long the rocket will take to hit the ground after it's launched. Why am I using the quadratic formula to do that? No, I mean, why am I even, because I'm going to solve for t, basically. And I'm telling you not to worry about trying to factor it. I'm trying to, don't complete the square because that's long. I'm giving you a hint. We're solving for t. We're going to use the quadratic formula to solve. So what's A, what's B, what's C?
Negative 16.
Is A. Mm-hmm.
And B is 116.
All right.
C is 1.
Oh, all right. So we're going to go negative B is negative 116 plus or minus square root. I'll write the formula at the top so you guys can see it.
No, we're on
No, this is B.
Yeah, I'll write that too.
Plus all of this into the quadratic.
Yes.
B squared. We gotta square that.
Yes. What's 116 squared, anybody?
Oh.
There's supposed to be more stuff written down.
Yes.
1, 3, 4, 5, 6.
Yeah.
1, 3,
gonna
4,
try and say
5,
that.
6. Minus 4 times A,
4? Oh, minus 4.
which is negative 16, times C, which is 101. All over
Can't read.
2A. Do you want to just write out what 2A is?
Yeah,
or do
it's
you
a
want
negative 16.
times 2, which is negative 32. What did I tell you to do next on your calculator? Do you remember?
Round to the nearest tenth of a second.
Yeah, but I mean when we were doing this the last time.
Then you do the inside.
That
of the
inside
square
that
root.
square root. So we're going to put that 1, 3, 4, 5, 6 minus
Negative 6. 4.
minus
Times
4
negative
times
16.
negative 16 times 101.
So 19,920.
Yep.
We're going to do the negative 16 plus or minus square root 19920
I'm running out of room. You should have given us more room.
Yeah, I'm running
all over negative 32. Now, I'm going to teach you how to use your calculator. It's because if you don't do it correctly, you won't get the right answer. Because you're going to want to put this in your calculator, correct?
Is that still under B?
This numerator has to go in parentheses. We got a negative 0.785. You can write that down, but we're trying to find time right now. Can we have a negative time? Can we have a negative? The negative 0.78 something or other is not a valid answer. So we're going to have to go in here and use this plus or minus and change that plus or minus. We did the plus. Now we're going to change the minus. When we do that, we're going to use the second enter on our calculator and just scoot back and change that positive to a negative and hit enter. Let's see what we get when we do that. We got 8.03, but if we look, actually 04, 03, 55, 6 something, okay, and was positive. That's a good thing. So, but we look here at the instructions and it says to round to the nearest tenth. That's one decimal. So that's the 8.80. This 3 doesn't make it change. It stays the same. So our answer is 8.0 seconds. Let's move on to letter C. Letter C here says, how long until it reaches its maximum height? Well, if you remember, this is a parabola. And since it's got a negative a right there, we're going to have it upside down. And that maximum height is going to be at the vertex. The vertex, to find the coordinate of the vertex, the formula was x equals negative b over 2a. But we don't have x's. We have t's. So we're going to substitute this value right here, this x, for a t. And we're just going to substitute in. We have our b value. If you remember when we wrote it earlier, our b value was the thing that wrote the v0, which is our 116. So we're going to do that. T equals negative 116 over 2 times a, and a is the negative 16. We put that in our calculator. We get 3.625. Be very careful if you're putting that in your calculator that you make sure this whole thing's in the denominator. There's a couple ways you could do that, is by putting parentheses, or you could just in your head know that that's negative 32, and that will also, you can just put it right in there. This is seconds. This is letter C, 3.26, but we don't need to have that many decimals. Letter C says to round to the 10th of a second, so we're going to, that's right here, and the 2 doesn't change that, so it's 3.6 is letter C. Let's do letter D. We will need this part here, so we're going to keep it for letter D. It says, what's the maximum height? We talked about this, that this is a parabola, and it's an upside down parabola. That maximum right there is the vertex. We found the x coordinate of the vertex, and now we need to find the y. The y will tell us how high it's going. So then let's plug in this 3.6 into that equation. That equation was done in A, and here it is at up the top right there. And so we need to plug this 3.6 in for each of those t values. I'm going to do that on my calculator. I'm going to just type it in. Type in the negative 16 3.6 squared plus 116 times 3.6, and add the 101 to it and hit enter. And I got 311.24. Again, we're rounding to the 10th, so I only need the 2, and this is feet. All right, we finished number 8. Let's move on to see what we've learned today. You did an overview of the graphing parabolas and what the equation tells you about the graph, or what the graph tells you about the equation. We went backwards and forwards, right? Then after that, we used this formula. You wrote it down. We dissected each of the pieces of it, and this was for some kind of projectile motion or something being dropped, something that is affected by gravity and its motion. I hope this has been helpful.